Well, during this presentation, I will be giving an update on my thesis project on atmospheric rivers. So what is an atmospheric river, or an AR? It is a concentrated and narrow band of moisture moving through the atmosphere that typically brings a ton of precipitation to a particular area. The American Meteorological Society and NOAA both came out with their definitions within the last 10 years. One of the most important variables when calculating an atmospheric river is integrated water vapor transport, or IVT. And this is looking at a column of the atmosphere and calculating the zonal and meridional winds, specific humidity, and pressure at a given location. And on the image on the right, in addition to the definitions, has also come out a scale for West Coast ARs. And so on our x-axis, we have AR duration in hours, and on the y-axis, we have IVT magnitudes. And so this becomes very important, especially for my research, which I've adopted for East Coast ARs. And you can see that you can have a whole bunch of combinations between duration and IVT thresholds, as I like to refer to them. And this more evenly, although there isn't an even distribution, more evenly distributes different kinds of categories of ARs throughout 1 through 5. So here's a West Coast AR. This is from January 1st to the 11th. The lighter colors are rain, and the blue colors and purple colors are snow. And so this AR was most predominant on January 9th, 2017. And so you can see that in its definitional form, an AR has a lot of moisture at the front of it. And this particular AR hit California. So during my last presentation, I gave an idea that there are 3 stages to meteorology when studying an event, and that's any event in meteorology. There's identify, analyze, and prediction. And within the analyze phase, there can study the impact of the event as well. And so the East Coast ARs and the people studying them are very much in the identify and analyze phase. And that is also the direction I'm taking with my research. So in New Hampshire, there's a team studying East Coast ARs. And so they have become a guide for me in terms of how I'm going to study ARs in my region. So within this box up here of Google Earth, within the 4 pins here, is the region that they were studying. And so they found that on average, 101 ARs were happening per year from a 1988 to 2017 climatology report. And sometimes you can have lower than 101 or higher than 101, but on average, they were finding 101 ARs as their frequency per year. And so from that, they were able to dive a little bit deeper and look at the different categories of ARs that were happening during each year and then over that 30-year period. And so they found that longer duration ARs are typically in the warmer season, so spring and summer. And these would typically last longer if they were more powerful or if they were a higher category. But in the winter season, they can reach a higher IVT magnitude or threshold, but they wouldn't last as long. So that's an interesting thing to look at, especially for me, as that'll become sort of a guide in the way that I look at ARs when I get more results from what I have right now. And so one of the other interesting things that I found was the average of duration was 48 hours between all of these ARs, whether it be a Cat 5 or a Cat 1. And so what am I doing? Over the next couple of slides, I'm going to show you some of the preliminary results that I've gotten from my research in ARs. So I have a couple frequency charts. I have a couple animations showing ARs and specific humidity, which is a direct connection to it, and a cross section of a river, which for the hydrology fans should be a little bit fun. So this is a 2010 to 2019 IVT value graph. Basically, we took my region that I was looking at and calculated IVT values. And to put quite simply, this is a hot mess. I cannot get anything but maybe 4 high-level IVT events up here. That's pretty much it. And so this is 10 years worth of stuff, and there's a lot to break into here. So looking at 1 year, it's still a little bit messy, but a little bit cleaner. I stretched it out here even to see that, an IVT needs a minimum of 250, but they also need a duration of at least 24 hours. And so from here, you can't really see that 24 hours has passed from these points. To even go a little bit further, this is 3 months from 2010. And basically from all the values that we saw from the first graph where it had 10 years worth of data, I can put that into an Excel sheet and I can get a chart like this where I can distribute the AR categories from 1 year, since that's all I have right now is my preliminary results, through 1 year. And so it's good to see that AR1s are most predominant, because that just means a healthy amount of moisture is coming to the area, whereas damaging winds or damaging flooding from AR4 and 5s would be, having that constant would be really bad. And then from that, we can build a stack bar chart, which will become really important later in my presentation when I can show what I can do with this kind of stuff. And so this is an East Coast AR example. This specific case study became a good example for what kind of results I should be getting. This AR lasted for 6 days on the entire East Coast from July 20th to 26th of 2018. This is a water vapor map, and the bottom is the accumulated precipitation at Baltimore Airport in millimeters. And so the star will be shown here as well. And so it's still Baltimore. And so this graph, or this animation, shows specific humidity as the colors, which is a direct relation to moisture. And the isobars are IVT values at 750, 1000, and 1250 at 925 hectopascals, which is relatively closer to the surface. And the arrows are wind direction and wind speed. And so while the AR lasted from the 20th to the 26th, this entire data is from July 20th to the 29th. So this is a closer view of what you just saw. And so those stars still BWI. And hopefully we'll see that the IVT contours show up relatively about here. And so so you can see that specific humidity is directly related to IVTs. And within that equation, it is a direct relation. It is multiplied, not divided by, basically. And so this is the Chesapeake watershed, Delaware watershed, the entire New Jersey state, Delaware. That's what that outlines there. And so take a mental snapshot of this, and we see a cross section of, and we're looking through the atmosphere. Imagine you're standing on top of a hill and looking through the atmosphere. And the top here, you have specific humidity. And at the bottom here, you have IVT values. So when you see more colors and higher specific humidity, you can also see that the IVT value goes up. And so we just saw it. There's another example that'll show up really shortly. And so this is important in terms of looking at big AR category events. And so this is something I hope to explore more in my semester 2 research. So some of the challenges and future work that I plan to do, coding is a huge challenge, as one can suspect. Some people have instrument failures. Well, the instrument failure for here, sometimes for me, is one line of code breaks the entire system. And so it's really frustrating sometimes, but it's definitely something I need to learn as I continue my journey in the meteorology field. I know for me, one thing I could definitely improve on is maybe better colors within my animations. Make it a little bit clearer, make it the colors a little bit more contrasting, so I can show that kind of stuff. And so there's a lot of coding challenges, and so some of the future work, in addition to that, is fixing some of those challenges. And then, if you remember earlier, I brought up this idea of stacked bar charts, and so this chart right here I have on the right is for 10 years, but my hope is to interpret 40 years worth of data from 1980 to 2019. And then if I'm lucky enough, if the data comes out from 2020, and I think that would be really, really cool by the time that the end of the semester 2 comes, the end of the school year comes around. Thank you very much. If you have any questions, please write me an email. I'll leave it in the comments. Just as a side note, this is the interface that I typically deal with from day to day when finding IVT values or analyzing ARs. Thank you very much, and please stay safe.